Hello everyone, welcome to this demo that is about optimizations in prescription loading. So if you are following Project Thoth, you are already familiar with the prescriptions repository that keeps information about open source Python packages and also about runtime environments that are used to run Python applications. So this repository contains YAML files that are specific to some packages, and these YAML files state how the resolution process should look like, or how the desired resolution process should look like in order to deliver high quality software packages to environments. Previously, we released this repository as a container image, so everything that was present in this repository was copied into a container image that was released and used in a deployment. So once deployment started using these prescriptions and prescriptions container image, the content of container image was copied to the recommendation engine, and then the recommendation engine loaded these prescriptions, these YAML files, and they were used to guide the resolution process and also provide information to Thoth users. Now this changed. So from the most recent release, we are changing this flow, and how prescriptions are handled today. So this repository is cloned on each advisor release, and prescriptions are loaded into memory, in which case there are constructed Python objects. So prescriptions are loaded into memory, they are verified that they are correct. And once they are loaded into memory, the whole or part of the memory that keeps prescriptions is dumped to disk and stored as a pickle file. Then this pickle file is used in deployment. When the recommendation engine starts, the pickle file is loaded into memory, but as it already stores prepared Python objects, they can be immediately used during recommendations. So this is the main idea behind the optimization. And if we take a look at deployment, so now we can try to ask for an advice. So we are calling Thamos advice, no static analysis in this case. And the recommendation, once the recommendation engine computes results, we get them back in a form of justification printed to the user. Now, here you can see all the recommendations that are produced by the recommender system. But what is interesting for us in this demo is the actual resolution log. So if we ask for Thamos log, here you can see that prescriptions were loaded. They were loaded at this time, and prescriptions were available at this time. So here you can see that the whole overhead of loading prescriptions and starting using them is less than 0.002 seconds in this case. When it comes to the size of the prescriptions database that was used in this particular case, it was something more than 50,000 prescriptions, and in total it was more than 220 megabytes of YAML files. So here you can see that once prescriptions are prepared for the actual run by the recommendation engine, you can see that the overhead is smaller. Before, it took more than 30 seconds to load these prescriptions, and there was also overhead in copying them, so the recommendation engine can start using them. Before the whole workflow before took more than 1 minute. With this optimization, it's quite evident that we can scale the prescription database even more. So if the database will grow 10 times, we can still we are still able to use them in the recommendation engine, and they can be used to guide users to get better Python dependencies. So this way, I would like to thank you and see you next time.